Hey there everybody, this is Mr. Dickin here. In this video we're going to be discussing the Unit 2 content, and Unit 2 will be discussing quadratic functions, so anything that has to deal with an x squared. Now, one of the key foundations of dealing with quadratics is learning how to break quadratics down so that we don't necessarily have to deal with a squared term every time. So in doing that, we need to practice factoring. So we're going to start off with just a quick little recap of factoring out greatest common factors, or GCFs. Now, greatest common factor is the biggest number or biggest factor that goes into two or more terms. So common means it's shared between two different pieces. So if I look at my first equation here, or not equation, expression, my apologies, I have 6x and a negative 15. I want the biggest number that can go into a 6 that can also go into a 15. Well, that common factor would be a 3. Well, if I factored out a 3 from each of these, I'm essentially dividing each of them by 3. So if I were to divide out that GCF from each of those, I would have a result of 2x resulting from 6x divided by 3 minus, 15 divided by 3 is 5. Now, I can always go back and double check. If I were to distribute this in, this 3 times 2x is 3 times negative 5, I should result back with my original problem. So it is very simple and quick to kind of double check your work as you're going through. Let's see another one. 12x minus 14y. 12x minus 14y. So I'm looking at the numbers here, the coefficients. 12, negative 14, positive 8. Well, the fact that they're all even numbers tells me I know for a fact I can take a 2 out of everything. 3 also goes into 12, but it doesn't go into 14, so 3 won't work. 4 goes into 12, goes into 8, but not 14, so 4 doesn't work. 5, no. 6, no. 7. 7 goes into 14, but not 12 or 8, so it looks like 2. 2 is going to be the GCF here. Well, if I factored out a 2, I then need to divide each one of these values by 2. 12x divided by 2 is going to give me a 6x, negative 14y divided by 2, negative 7y, and 8 divided by 2 would be a 4. So those leftovers are what go in the parentheses here. And just like before, if I wanted to double check, I could distribute this right back in, and if I do, I would result with my original expression. Well, now let's get into variables. If I want to factor out the GCF, the greatest common factor, when dealing with variables, I have to kind of take into account with the exponents and what that truly means of how many x's are represented. Just in looking at the numbers here between a 2 and a 5, those coefficients, there's really no common factor. I mean, I could take a 1 out, but that's not really going to do anything. So I might need to rely on my variables. So 2x squared is really 2 times x times another x. And then we have 5x over here. If I were to look at things that are shared, or what could I safely divide out of each of these terms, well, I could safely divide away one single x. This 2x squared term, this has two different x's to give up. This 5x, this has at least one x that we could give up. So my GCF here would be a plain old x. If you wanted to, you could write a 1, because we could technically divide a 1 out of the numbers, but you don't have to write that 1. And if I took away one x from each of these terms, I'd be left with 2x plus 5. 2x plus 5. And again, we get that by dividing away a single x from each term. So we divided out an x from each of those terms. All right, onward we go. Slightly more complex. 21x squared minus 14x to the 5th. Well, let me first start off just by looking at the numbers here. I've got 21, I've got 14. GCF there, I could divide those both by 7. And then if I look at the variables, I've got x squared, so that's 2x's, and x to the 5th, that's 5x's. Well, I could safely take away 2x's from this first term and the same amount from the second term. So my GCF is going to be 7 x squared because I'm taking away 2 x's. Now, what are we going to have left over? Let's see. If we're dividing the numbers by 7, 21 becomes a 3. Negative 14 becomes a negative 2. Here, if I started with 2 x's, but I factored away and I divided out 2 x's, I divided away an x squared, well, there's just no x's left, right? Those guys would cancel each other out. On the next term over here, 14x to the 5th, I had 5 x's, but I got rid of 2, so there are 3 x's remaining. So x to the 3rd. So 3 minus 2x cubed would be our answer there inside the parentheses. 7x squared times the quantity 3 minus 2x cubed. Let's crank up the challenge level, shall we? 2x to the 4th y squared plus 6x squared y to the 3rd minus 10x y to the 5th. First things first here, I would strongly advise if you don't see an exponent on any variables, go ahead and throw one on there. So I just tacked a little 1 onto the x. And for me, that's just a nice visual reminder that this x and the y, they're 2 separate entities. They are connected by multiplication, but I just don't want people to accidentally assume that that is saying xy to the 5th, because it's not all one unit. All right. Let's take a look at our GCF. First, let's take a look just at the numbers. I've got a 2, I've got a 6, I've got a negative 10. Well, I can divide everything by 2. They're all even. So my GCF is going to include a 2. Then let's look at our letters. First term, I've got 4 x's and 2 y's. Second term, I've got 2 x's and 3 y's. Third term, I've got 1 x and 5 y's. I want to figure out how many letters can I safely take away from every single term. So I've got 4 x's and 2 y's. I've got 2 x's and 3 y's. And I've got 1 x and 5 y's. Now, when I'm taking things away, holy cow, what happened over there? My stylus just went crazy. As I'm taking things away, I have to take or divide out the same from every single term. So this first term right here, well, yes, it does have 4 x's it could potentially give up. This one only has 2, so I can't safely take 4 x's away from everything, right? This one here has 3 y's, but I can't take 3 y's away from everything because this guy doesn't have 3 y's to give up. So in general, when you're trying to figure out what you can divide out or what you can factor out, general rule of thumb is look for the smallest exponent you see on each individual letter. So x to the 1st, 1 would be the smallest exponent there, and for y's, we have y to the 2nd. So that's going to tell me my GCF for the variables. Now that's assuming that x's and y's show up in every single term, and in this case they do. So I can take out 1x and 2 y's, x, y squared. So that's essentially what I'm dividing away from every single one of these. All right, so first term, 2 divided by 2 becomes a 1. You can write the number 1, but you don't have to. X to the 4th, but I take away one of the x's. That would be x to the 3rd. And right here, y squared, so 2 y's, but I take away 2 y's. There are no y's left over. On to the next term. Every time I throw a plus sign, that starts off the next term. 6 divided by 2 is 3. I started with 2 x's, but I got rid of one of them, so I have x to the 1st. Y to the 3rd, but I got rid of 2 y's, so I have 1 left over. Next term, 10 divided by 2 is 5. I don't have any x's because I divided it away, took it away, but I would have 3 y's left over. 3 y's left over. That would be our final answer. Yay! All right, last problem. Here we go. 3 letters. Boom, boom, boom. All right, I've got 6x squared, y z to the 4th, and 15x to the 3rd, y to the 4th, z squared. I want the greatest common factor. So just looking at numbers, I have 6, I have 15, GCF would be 3. So the coefficients then would turn into a 2 and then a 5. As far as variables go, I've got 2 x's over here on the left, 3 on the right, so I can take away 2 x's. As far as y's go, I have 1 y on the left, 4 on the right side, so remember I'm looking for the smaller of the two, so I can take 1 y away from each of those. And then z to the 4th, z squared, so I have 4 z's here, 2 here, so I can safely take away 2 z's from each. So I'm going to divide each one of these terms by my GCF, which would be 3x squared yz squared. So that'll go down here as well. 3x squared yz squared. Okay, first term, we started off with x squared, we divided by x squared. Those are gone. Y to the first divided away, y to the first, those are gone. 4 z's took away 2 z's. There would be 2 z's left over, so z squared is what that turns into. Next one, 15 divided by 3, 5, we got that. We had 3 x's up top, 2 down below. After things cancel out, I would have x to the first, so just plain old x. I've got 4 y's and 1 single y being divided away, so if I had 4 y's, divided one of them away, I would have 3 left over, so y to the third. And then the z squared, I had 2 z's, but I divided 2 z's away. Well, I would just have nothing left over. So this right here is our final answer. All right, that's all I've got for this first target video. You know the drill. If you have any questions, please do not hesitate to reach out. Good luck, have fun, be safe, roll tide.